Students, this is lesson 6-4 on page 407. Okay, this one is application of linear systems. And it's reminding us that there are three methods that I have taught you. And at first, I taught you graphing, then I taught you substitution, then I taught you the elimination method. Question here is, when do you use each method? Now, I have some problems here set up to kind of display that, but I just wanted to actually go into the book. The lesson again starts on page 407, and it gives a kind of detailed explanation of when you should use these, and I wanted to read these to you. So it's concept summary, choosing a method for solving linear equations. When do you use graphing? When you want a visual display of the equation, or when you want to estimate a solution, would probably be the best time to use graphing. Also, I might want to state too, if both of your equations are already set up in slope-intercept form, then it might make it pretty easy to graph them. The second method is substitution. When do you want to use substitution? When one equation is already solved for one of the variables, or when it is easy to solve for one of the variables. Or basically, as I had stated in a slightly different wording, when one of your variables is isolated, if y is already isolated or x is already isolated, then substitution will be super easy. Or if it's like really easy, like one step to isolate it. The elimination method, when the coefficients of one variable are the same or opposite, or when it is not convenient to use the other two methods of graphing or substitution. Okay? So when the elimination method, it's like, oh, well, I have 5x and negative 5x. Then it's like super easy to use that method. Okay, so let's take a look. And the question for today's lesson is like, which method do you want to use? So let's take a look at our first equation, or first system rather of equations. I have 4x plus 5y equals 3, and I have 3x minus 2y equals 8. So let's look at this for graphing. Is this information written in slope-intercept form? No, it's written in standard form. Okay, let's take a look at it for substitution. Is either variable isolated? No, y's and x's all have numbers and coefficients attached to them. Would it be really easy to isolate one of them? No, it's going to completely change the entire equation if I wanted to isolate x or y. Okay, let's take a look at the elimination method. Well, the elimination method said, is one of these opposite of each other? No. 4x and 3x is not opposite, and 5y and 2y are not opposite, or the same where I can subtract it to, to do the opposite operation. So in this case, I would use the elimination method. Now, in this case, even though there's no opposites, since there's no good reason to do it by graphing, and no good reason to do it by substitution, elimination is probably the best method. And in this case, then I would probably want to raise one of mine. So I could take 2 and 5, and I can raise them to 10y, I put x instead. Or I could have 4x and 3x and raise them to 12x. I'm going to write or in between them because I'm showing that I don't have to do them both. I just have to do one or the other. But I have to do it to both equations, okay? So if you don't remember the steps, please go back to the last video because I'm going to try to keep this one short. So which method would I use for this one? So my equation here is 2x plus 7y is equal to negative 20, and y is equal to 3x plus 7. So let's look at my three methods. Graphing. So if I were to graph them, obviously that deals with what the information is, because one of the questions for graphing is, well, if I need to display it, okay? But for just the purpose of solving, the way I would want to graph it is if both of them were in slope-intercept form, because that would be the easiest. They're not both in slope-intercept form. One of them is, but one of them is not. Substitution would be if one of my variables is isolated or super easy to isolate in order to do that. Well, in this case, y is isolated. So I'm not even going to go to elimination method. I'm going to pick the substitution method. So what I can do is, since y is isolated here, I can substitute it in for the value, and I'm just going to set this up. 3x plus 7 is the value of y, so I'm going to go 3x plus 7. And I'm going to rewrite the rest of my first equation here, because I can substitute this value in for y. Okay? Go back to the lesson, I believe it was 6.2, if you weren't sure of how to do to follow it through. But of course I would, I'll just do it. 21x plus 49 is equal to negative 20. 2x plus 7 plus, okay, 7 plus 49 is 56, so I combine my like terms. 2x plus 21x is 23x plus 56 is equal to negative 20. Subtract 56 from both sides. Negative 86. 23x. Yeah. Divide both sides by 23. Okay. And I'm just going to do this the lazy man's way and say x is equal to negative 86 over 23, since my answer is going to be a fraction. Now let's take a look at the last one. So I have y is equal to 7x plus 2, and y is equal to x minus 4. So which method would I use for that? The elimination method, let's see. I could use the elimination method, but I mean, it looks like y here is the same, so I could definitely do that. The substitution method, I could easily do that too. I'm going to pick the graphing method. Why? Because both of these are written in slope-intercept form, okay? So for the last one, I can use any method. To be truthful, I can use any method for any of the three systems that I had here. But again, it's kind of like using your brain to determine what's going to make this the easiest for me, what's going to be the most efficient way of doing it, and in the end, what's going to give me the most or best information that I need, okay? And again, each question you have to sort of ask those three questions too, okay? Easiest, most efficient, and the one that's going to give me the information that I need the quickest, okay? All right, well, thank you very much, and I hope you enjoyed this lesson.